Let's look at the position data table in the XGPM software. We have already created a project and are online with the motion controller. We will be accessing the position data table for Axis 1. To do this, we will go to the project window on the left side of the screen and expand Axis 1. We can then double-click on Position Data. This will open the Position Data window. For our project, we have the maximum of 400 position data rows. Each row has 13 columns for the various values and functions possible for a position data point. At the left end of the window is a list of index numbers for each position data row. This number is the primary identifier used to reference the data point from the Command Tool window or XPM function blocks like the IST block. The axis being edited, in our case Axis 1, is shown in the top left corner. The control type determines which type of movement the row executes. There are absolute and incremental moves, interpolations, etc. Please refer to the help files and product documentation for more details on each. The operation type determines what action is taken after a step is executed or called. Each operation type has a different behavior depending on the control type being used. Single end, single keep, and single continuous are the most commonly used options. Again, the help files and product documentation will contain details for each type. Target position and operation speed are the location or direction of the move and the velocity it is executed at. Different control types use these numbers differently, so please refer to the documentation for details on what information to enter. Accel number and decel number refer to the preset acceleration and deceleration times used for the move. These are configured in the axis parameter window and are unique to each axis. They are the times measured in milliseconds and are used to calculate the motion profile for the position data point. M code refers to a unique movement code for this index number. When this index is being executed, the M code value will be stored in the PLC's flag variable memory. There are a series of function blocks, parameter settings, and variables that need to be configured and deployed properly to allow this feature. Please refer to the documentation for more detail. Dwell time is how long after completing the step the system will wait to take the next action. Some operation types will move to the next position data point after the dwell time, and others will simply stop. Subaxis setting is used to link multiple axes together for a blended interpolation move, such as a 2-axis circular or 3-axis helical profile. The circular interpolation auxiliary point column is used in tandem with the target position column to define an arc for a circular interpolation move. The way the system uses the auxiliary point in the calculation is determined by the circular interpolation mode column. The circular interpolation turns column determines how many circles will be formed with the move. Finally, the helical interpolation allows you to set a third axis in sequence with the first two for a three-dimensional interpolated circle, forming a helix. It is useful to note that any of the XGPM data table values may be edited using the XPM SMD instruction. This allows the programmer to alter the data table using the PLC code during project execution. As we start to look further into these motion interpolations, it will become apparent that having multiple axes position data tables opened and editable at the same time will be key for coordination. This can be easily accomplished by opening Axis 2's position data table and then tiling them horizontally or vertically. We go to Window and then select our desired tile option. This will work with as many axes as necessary. While there are many ways to command motion with the XGB PLC, any interpolated moves will require the use of the position data table. This is also a way to accomplish a sequence of pre-programmed moves, as well as a location to store multiple sets of moves in a multi-move program. Understanding the position data table and its various fields and functions is key for motion programming with the XGB.